If you have a centralized air conditioning or HVAC system in your home, running a single window air conditioner on solar can vastly affect your monthly utility bill. I've spent some time working on and also paying the bill for a centralized HVAC system, and I tell you, a window unit beats it every day of the week in terms of efficiency and cost effectiveness. Hi everyone, Dave here. In this video, I'm going to present my experience and research in air conditioning a single room of a typical house using off-grid solar electric power. This video is great for people who want to learn about running an air conditioner on solar and for people who just want to reduce their electric bill. Air conditioning is one of the single largest expenses for a typical household in the summer. Running even a single window air conditioner completely on solar power will make quite a difference in your monthly electric bill, but is it really worth it? In this experiment, we're going to have 5 100 amp hour 12 volt lithium iron phosphate batteries to work with. And just a quick note here that this video is sponsored by Cyclenbat, and they sent the batteries to me. I'm not using any affiliate links or attempting to sway you. My desire is to make videos that are useful and informative to people, and I'm not an influencer. In fact, I hate that term. Cyclenbat has 2 versions of this battery. One has Bluetooth and the other does not. And of course, the Bluetooth version can be monitored in real time using an app on your phone or tablet. If we take into account the electrical efficiency of these systems as well as the power losses, we're looking at around 5 kilowatt hours of storage. If you want to quantify this in terms of what your electrical utility bill is, just multiply 5 times whatever you pay per kilowatt hour. If it's 20 cents, we're talking about $1 of kilowatt hour energy storage in these 5 batteries, more or less. So to quote unquote get these batteries to pay for themselves, I would have to cycle them 100% to 0% about 1,000 times. But that's only the batteries, not the other components in the system. So now for a quick solar reality check. Each of these batteries retails for about $169.99 for the non-Bluetooth version. That's around $900 in batteries. I've allocated about $150 for an MPPT solar charge controller. I have about $500 of solar panels sitting outside, and for the inverter we'll say around $200. It depends on what kind you get. And $200 for miscellaneous costs like cables, wires, and fuses. There is no actual guarantee that a solar power system will actually pay for itself in terms of kilowatt hours. But the idea that you can keep your room freezing cold without running up your electric bill or having an electric bill at all, I think is awesome. For running air conditioners on solar, I recommend you use only a sine wave inverter. Square wave or modified square wave inverters can cause harm and damage to appliances. If you want to learn more about that, be sure to watch my video on this topic where I went into it in great detail. The more expensive inverter technology-based air conditioners that have a variable speed compressor are significantly easier to run on a smaller and cheaper DC to AC power inverter than the standard kind that has a single speed compressor. If you're using a standard non-inverter type window air conditioner, be sure to take into account the startup surge, which is going to be 5 to 8 times the rated wattage on the label. For example, with a 500 watt air conditioner, it would be 2,500 to 4,000 watts. And it's better to estimate on the higher side of that. Then make sure your DC to AC power inverter has a rating at least that high, but ideally a little bit higher. In this video, I'm using an inverter style air conditioner, so I don't have to worry as much about the surge. The maximum amount of power this air conditioner can use is less than the max rated power of my inverter, so I'm good to go there. As part of this experiment, I'm going to show you what the actual room layout is. We have 208 square feet for the main space, which is a bedroom, and I'm including the closet in the main room because it's always got the door open and so it has to be counted. Now there is an adjoining room of 143 square feet that has a door separating it from the main room. This allows me to run 2 experiments at the same time because I can cool a larger or smaller space, depending on whether that door is opened or closed. The walls are 20-year-old fiberglass, so probably an R15 roughly for the insulation value, 1,700 cubic feet for the main room, and 1,072 for the adjoining room. So the total space to be cooled will be as high as 2,770 cubic feet, or about 350 square feet. So this is the latest iteration. My goal here is to keep the system as simple as I can, and pardon all the wires going everywhere. That's the reality of what I do. I've set up a battery bank. I've used the 5 Cyclenbat batteries, and those are all in parallel and they're running at 12 volts. I've decided to save costs by skipping the battery meter and just using a simple LED voltmeter. That's about $4. I did hook up my digital voltmeter and it's close enough. Now you might be thinking this is like from Stone Age technology, but I've been doing this for over 10 years and I've learned how to track my state of charge using a simple voltmeter. However, I prefer a 3-digit precision voltmeter, and I will link the video in the description where I talked about that. But here I'm really going to cheap out. We're just going to use that $4 voltmeter, which only has a single digit to the right of the decimal place. Now for this experiment, I'm using an MPPT charge controller. This is the WZR-ELB 60 amp model. This is a Junbi-PAW, or Junpaw, however it's pronounced, pure sine wave inverter. The air conditioner is an 8000 BTU inverter style unit. This means it has a variable speed compressor. These types of units have horrible power factor. They waste a lot of AC power. So this air conditioner can waste, in my calculations, as much as 20 or 30% of the AC power that's put into it. But it's quiet and it does a really good job. Downside, it's very complicated, has a lot of electronics, a lot of stuff going on in there. It's much more complicated than a simple window air conditioner you would traditionally find at a store. I like simple and robust mechanical control air conditioners, but this one has its advantages, I must say. Now, between the amount of power that's wasted from the solar panels to the charge controller, which can be as much as 5 to 10%. It might be more. It depends on how hot the charge controller is. It depends on the design. It depends on the PV voltage versus the battery voltage and other factors. Plus the power that's wasted in the inverter, which is probably going to be something like 10%. It might be even 15%. It depends on a lot of different things. And the power that's wasted in the air conditioner itself, which can be as much as 20%, 30%. It depends on a lot of factors as well. You could be wasting 40, 50% of the power. But efficiency is more than just electrical. There are many different aspects. So in engineering and in research, I like to consider all aspects, or at least as many as I can humanly manage to consider. Spoiler alert, I've been running a off-grid solar air conditioner experiment for a long time. I've used different air conditioners, done a lot of research into it. Even though I don't like complexity, I've found that the inverter style air conditioner, if you can get them, these do a much better job on solar overall. It does not mean you can't run a standard, ordinary window air conditioner off of solar power. It's absolutely just as valid, just as fine, and I'm not saying you can't do it or shouldn't do it. In this experiment, though, I've started using this inverter air conditioner, and I've also done it with other ordinary ones as well. I'm also using a simple watt meter here to track my power utilization, and it gives me the real-time wattage as well as the kilowatt hour that it's pulled in each experiment. And now I'm going to present my results and findings. And I hope you'll keep in mind the structure and the type of room and construction, because that matters. Windows, wall insulation, ceiling height, square footage, whether it's facing the south or not, all that stuff matters. On a not so hot day, it's child's play. 500 amp hours of Cyclenbat lithium iron phosphate batteries, brand new. And that window air conditioner, which is 8000 BTU and can draw several hundred watts, even 700-800 watts, along with a sine inverter and this charge controller, it's child's play. When the weather turns hot, I find that I have to close the door to the first room, because if I don't, that thing there will drain the batteries really, really quick. During the daytime, when there's solar power, it's not so difficult. I can get 600, 700, 800 watts of solar and put it right into that AC all day long. That's not a problem. But when the sun goes down, these batteries can be drained flat in just 4 or 5 hours if I'm not careful. It's challenging. However, there's good news. This type of air conditioner can throttle down to where it uses only 100 or 200 watts. But that introduces another problem. It's going to use less power, but the relative humidity of the room is going to start going up. Another area of research, which is humidity control. That is a small compressor-based dehumidifier that only uses about 130 watts. Relative humidity of the environment is a #1 concern when you're in an environment that has humidity. And we are. I'm located in an area that sometimes has major humidity problems. As soon as that air conditioner slows down and stops cooling as much, it will also not dehumidify quite as well. And then the relative humidity will start to rise, and at 60% humidity, mold becomes a problem. Believe it or not, that's why the air conditioner was invented by William Carrier originally, was to control the humidity in a space, not the temperature. The fact it cools your room down is also actually a side effect. So if you want to control the humidity, a really small dehumidifier in the room can yank out several pints of humidity in a very short time and turn off and save you a ton of power. I hate to turn this into a dehumidifier video. Air conditioners, believe it or not, are dehumidifiers. That is actually their primary purpose. Lowering the temperature of the room, of course, is a bonus, and it's very nice. So my conclusion is, for a room that's the size of the one I'm showing you in this video, you really need to double or triple or even quadruple your energy storage to be able to run an air conditioner like that with impunity. So the moral of the story here is, this is effective, but not with impunity. And so I do have to manage my energy balance, and I have to make sure that voltage doesn't go too low, because if it does, the system will shut down and I won't have any air conditioning. Window air conditioners tend to get dirty. The condenser coils in particular are often overlooked, and those are exposed to the outdoor air and they tend to get very, very dirty. Keeping the evaporator coils and condenser coils very, very clean and also cleaning the internal filter is important because that air conditioner is already wasting quite a lot of power, and if the coils and filter get dirty, that just causes it to use more power in order to do the same amount of work. And I just want to be clear here that I'm not trying to sell inverter style air conditioners. In fact, I don't really necessarily recommend this brand, but that's what was available and I bought it. I like simple stuff, simple on-off switches, and yet this machine has several different advantages, and that's why I've been doing the research to see, is this any better for solar power versus a standard window air conditioner? If your inverter is strong enough to handle the surge day after day, year after year, every summer of a standard non-variable speed compressor air conditioner, honestly, I'd go for the standard type of air conditioner that just has a single speed compressor. Unless, of course, you really, really like this type. This kind of air conditioner is so similar to a mini split air conditioner, it's not even funny. Even the coils inside look like a mini split air conditioner. And to me, that's really fascinating. So how many kilowatt hours is this system consuming? Well, it's based on the temperature outside. Obviously, right? When it's really, really hot, that thing cranks up and uses like 500 to 600 watts or maybe more than that. It's okay during the day. That can cool the room. It's just fine. What I have to do is, at the end of the day, I have to make sure that voltage is as high as possible and these batteries are as full as possible, because if I don't, probably 4 or 5 in the morning, my batteries will be empty and I won't have any air conditioning. Besides, I don't want to run these down to 0%. I don't ever run my batteries flat unless I'm doing a review or a test, and I still hate doing that. To cool this main room, not counting the back room, this air conditioner can consume as much as 5, even 6 or 7 kilowatt hours of electrical power to do that job. Unless I'm a little bit careful with the thermostat settings and I don't set it to 65 degrees like some people do. As long as the humidity is controlled, I don't mind 75 degrees Fahrenheit, and even 76, 77 degrees might be okay as long as the humidity is under control. For me, really my concern is the humidity, not so much the heat. If I crank that thermostat down to the 60s, there is no way the system could keep up. It's going to drain the batteries flat. And that's the reality of solar. Does this stuff pay for itself? If you just look at the kilowatts and the cost, it's kind of hard to do that because charge controllers, air conditioners, inverters, all this stuff, most of it wears out. A set of good quality copper cables is a wise investment. They have no moving parts and they pretty much never wear out. Batteries, they wear out. Inverters wear out. Charge controllers wear out. So we have to keep those things in mind. If you're able to get the system to push the same number of kilowatt hours as it cost you to build it, you could say, quote unquote, it's paid for itself. But I think that's rather challenging to achieve because sooner or later, something's going to burn out. What I like to do is consider other value. For example, isn't it nice if there's a hurricane and you have no power for 2 weeks straight? This thing can keep your room cool and comfortable, boost your morale, and help get you through a tough time. To me, that's worth more than the dollar amount of kilowatt hours that I would get from a system like this. So to me, the reality of solar is that this equipment is wonderful and it does really amazing things. What's really important though is the freedom and independence of controlling and operating and owning your own means of production of electrical power, and the ability to do useful things with that power, like keep your room cool and not worry about a power bill and not worry about the power grid going down. And for me in my research, solar is also really about what it can do for the world at large, not just people like me who have all this stuff, but what about people who can't afford all these gadgets and toys? And by the way, I can't afford them either. These were all sent over for reviews. Believe me, I worked myself to death to get these things. I didn't get them for free like some people say. There's a lot of suffering and hard work that goes into making these videos and getting this stuff and doing the test because I'm an honest person and I do real work and real testing, real reviews, and real videos. But in some regions, just being able to afford a set of solar panels is the end of the day. They can't afford anything else. They can't afford all these other cool gadgets. So I've been doing a lot of research into simplifying, streamlining, and making solar much more robust. Part of that, I actually started using a solar power system that's off the electrical grid and it's pure DC. So no inverter, no charge controller, just solar panels, batteries, and some simple electromechanical components. And I use those to run as many appliances as I can with pure DC. They'll even run directly off solar panels with no battery at all. That system has not taken over my entire house yet, and I still have a traditional 12-volt system. I still use inverters and charge controllers and whatnot, but I think pure DC systems are the future. Eliminating the charge controller conversion from one voltage to another, eliminating DC to AC because AC is just a remnant of the electrical power grid, running DC straight into the batteries and then straight into the appliance. By the way, I'm still waiting for DC versions of this kind of air conditioner to become prevalent and common on the store shelves. Yes, DC window air conditioners exist, but they are so rare and hard to get. And often they're very, very expensive. Hopefully in the future, though, that will change. Thanks again to Cyclenbat for supporting this video, and also thanks to our friends and subscribers for watching, and I hope you enjoyed this video and found it useful. See you next time.